Hello, this is Pavani, Assistant Professor in IT Department. Now we are going to see about the Database Management System. Subject code CCS 3492. Actually, we are moving on to course 2. Okay. Design database using ER model and normalize the data. We are going to see about the Unit 2. Actually, Unit 2 is database design. First, we are going to see about non-serial schedule. Actually, non-serial schedule interleaves operation, transaction run concurrently, improves performance, increase system throughput, needs proper control, may cause conflicts, requires serializability testing, enhances resource utilization. Actually, in database management system, a schedule is the order in which operations like read, write, or commit or about mode of multiple transactions are executed. Actually, we need to see what is serializable schedule. Let me explain you. It is the result of same as some serial schedule. That is, transaction executed one after another without overlapping. Now you can understand what is non-serial schedule. Actually, it is one whose final result is not equivalent to any serial execution of transaction. This means it produces inconsistent data. It may cause incorrect result. It violates data inconsistency. Okay. Actually, why non-serializable schedule happens means because of lost update problem, write conflicts, improper concurrency control. Okay, moving on to serializability. Actually, it is the property of a schedule that ensures the concurrent execution of transactions. Produce the same result as some serial execution. This is the golden standard for correctness in concurrency control. Okay. In this, we'll be seeing about the serial schedule. Okay. It executes transaction one after another without interleaving. Okay. Actually, schedule in serializability if the final result is equivalent to the result of some serial schedule. Even if operations are interleaved, the output must be correct. C. Serializability ensures correctness of schedule, equivalent to serial execution, maintains database consistency, conflict serializability is common type, uses precedence gap, checks cycle formation, if no cycle, schedule is safe, guarantees AICD compliance. Moving on to conflict serializability, it's nothing but occurs when operation conflict. See, conflict seriality is a type of seriality when schedule can converted into a serial schedule by swapping non-conflicting operation. This is most commonly tested concept in database management system. Okay. Since we are looking into conflict seriality, we need to know what is conflict. Two operations are set to conflict if they belong to different transactions. They access the same data item. At least one operation is a write. Type of conflict will be read to write mode, write to read mode, and write to write. Conflicts happens on same data item. At least one operation is write. Read write conflict is possible. Write write conflict is also possible. Order must be preserved. Precedence graph is constructed. Cycle indicates non-serializable schedule. Moving on to view serializability. Actually, it is a type of serializability based on view equivalence of schedules. Okay. Actually, the definition will be schedule is a view serializable if it is a view equivalent to some serial schedule. Okay. View equivalence. Two schedules or view equivalence. if it satisfies the three condition only. Condition 1 is initial read condition. Actually, if a transaction reads the initial value of data item in one schedule, it must read the initial value in the other schedule. Read from condition means if a transaction Ti reads a value written by Tj in one schedule, it must read from the same transaction in the other schedule. And then last one will be final write condition. The final write on each data item must be performed by the same transaction in both schedules. More general than conflict serializability. Maintain read from relationship. Final write must match. Harder to test practically. Ensures logical equivalence. Allow more schedules. Ensures consistency. Moving on to need for concurrency. Need for concurrency, multiple user access database simultaneously, okay, and then concurrency improves performance, increase resource utilization, reduce waiting time, improves throughput, supports multiple user environment, essential for modern system, needs control to avoid errors. And then problems in concurrency. Dirty read occurs before commit. Lost update overwrites data. Unrepeatable read gives different values. Phantom read inserts new rows. Inconsistency may occur. Data anomalies arises. Needs concurrency control. Ensures isolation. These are the problems in concurrency. Moving on to concurrency control. It controls simultaneous execution, maintains isolation property, prevents anomalies, ensures serializability, uses locking protocol, uses timestamp method, uses validation technique, improves data reliability. Moving on to two-phase locking. Two-phase locking is a concurrency control protocol. It used to ensure conflict serializability in database system. It divides transaction execution into two phases for locking. Actually, locking protocol ensures serializability. The two phase will be growing phase and then shrinking phase. Growing phase acquires lock, shrinking phase acquires release. Okay, no new lock after release. Okay, actually, why we need two-phase locking is when multiple transaction executes concurrently, problems like lost update, dirty read, and inconsistent data can occur. Two-phase locking prevents these issues by controlling how locks acquired and released. Actually, basic concept of lock. See, shared lock, that is S lock for read, and then exclusive lock, that is X lock for write. Okay, the rules will be of two rules. Many transactions can hold shared lock simultaneously. Exclusive lock is allowed only if no other lock exists on that time. Two phases will be of growing phase and then shrinking phase. Growing phase requires transaction can acquire locks, cannot release any lock. Shrinking phase, transaction can release locks, cannot acquire new locks. And then types of two-phase locking will be basic 2PL like two-phase locking, and then strict 2PL two-phase locking. Basic 2PL follows growing and shrinking phase rule, ensures conflict serializability, and then may cause deadlock also. Strict two-phase locking. All exclusive locks are released only after commit and abort. Ensures conflict serializability, no cascading rollback, recoverable schedules. Most commonly used in real databases. Third type is rigorous two-phase locking. All locks released only after commit. This is stronger than strict 2 NPL. Okay. Moving on to strict 2PHL, two-phase locking. Actually, it is a modified version of two-phase locking that ensures both serializability and recoverability. Recoverability, no cascading rollback will happen. It is widely used in real database system. Locks held until commit, okay? Prevent cascading rollback. Ensures strict schedule. Improves recovery. Commonly used in DBMS. Maintain strong isolation. Reduce anomalies. Safer execution. Actually, it is nothing but it's also a concurrency control protocol in which transaction follows two-phase locking and release all exclusive locks one after commit or abort. How strictly it work means, which is under growing phase and then shrinking phase. Same likely said about shrinking phase and growing phase, the same one. And then the properties which includes this conflict serializability, recoverable, cascadeless, prevent dirty reads, and may also cause deadlocks in it. Moving on to timestamp ordering. Each transaction get uniquely timestamped. Older transactions get priority, ensures serial order, read and write rules apply, no locking required, avoids deadlock, may cause restart, maintain consistency. Thank you.